All right. Well, why don't I get us started? I think we've got a good group of folks here, and it'll be another minute or two before we get the content started. But first, hello, welcome everybody. I'm really glad you're here to join us for today's webinar, focused on the best practices for using Nix at work. So whether you're a longtime Nix user or you're just starting to explore how it fits into your organization, you are in the right place. And we're excited to talk about using Nix at work because it's an important piece of the Nix ecosystem. My name's Jeff Martins. I am the Chief Operating Officer at Determinate Systems, and I'm also going to be your host for today. So at Determinate Systems, we're dedicated to making Nix more simple, secure, and confident in enterprise environments. We build tools like Flake Determinate Nix, and of course the popular Determinate Nix installer, which powers, I think about 40% of all daily installs across the world. We also contribute upstream and across the Nix ecosystem, and we're lucky to count Ilko Dolstra, the creator of Nix, as one of our co-founders. But most importantly, we help organizations harness the power of Nix, whether that's for software development, infrastructure management, or secure and reproducible builds. So now, leading today's session is someone who has spent a lot of time thinking about the challenges of Nix at work, and that is my friend and my colleague, Luke Perkins. If you've been around the Nix community for a while, there's a good chance you've come across Luke's work, whether that's through his blog posts at Determinate or his own personal blog or other places, the talks he's given at NixCon and other conferences, or his contributions to upstream and the larger Nix ecosystem. He brings a deep technical expertise, strong focus on developer experience, and something I've really appreciated is his knack for making complex topics understandable, because he's helped me get ramped up at Determinate really well. So today he's going to walk us through some of the key lessons and the best practices for adopting Nix in the enterprise, covering not just what works, but also like some of the common pitfalls we've seen, how to avoid them, and some of the patterns that we've seen both in our past life as a company that did consulting and our current iteration as a software company. So before we jump in, before I hand it over to Luke, a couple quick things. We're saving time for Q&A at the end. I've enabled the Q&A feature in Zoom. And so as the talk goes on, if you have questions, feel free to drop them in the Q&A feature in Zoom as they come to your mind. And then at the end, I will moderate some Q&A, and I'm going to pick some of the questions, and Luke will share some of his thoughts. We'll do our best to get to as many of those questions as we can, and we can always follow up afterwards with other things. We've also enabled the chat feature, which many people are already using, so feel free to use that, chat with other people that are here, and get to know other folks in the Nix at Work ecosystem, because it is a subset of the larger Nix ecosystem. We all love Nix, but we have different challenges, whether we're using it for work or personally, and sometimes it's great to be around other folks that have those same challenges in a work environment. And then last, this is our first webinar. We plan on doing many more, and we are a startup. So we took the approach of let's give it a shot, let's throw something out there, and let's learn. So we're really excited to be doing this today, but we're new to it. So with that, we ask for a little bit of grace, but also most importantly, your feedback. Tell us what you think, and let us know how we can make webinars better in the future. Luke and I are already thinking about the next two, and if you have ideas about things you'd like us to present on in the future, let us know. All right, so with that, I'm going to hand things over to Luke to dive into today's topic. I'm going to turn off my camera, and Luke, I will let you take it away.
Hey, can everybody hear me okay? Jeff, can you hear me?
Yes, I can hear you.
Sounds great. Okay, thanks a lot for that great intro, Jeff. This is Luke here. I'm speaking to you from Buenos Aires, Argentina, the greatest city on the planet Earth. I would be curious if anybody else is coming from South America today. I'm extremely excited to see so many folks present and ready to talk about best practices for Nix in larger organizations. Let me just dive right in and talk about what I see as the promise of Nix. To me, what Nix promises most fundamentally is predictability, which is something that's all too rare in software development, as we all know. where we're constantly fighting against unpredictability and indeterminacy along so many different axes. Nix, on the other hand, because Nix the language offers pure evaluation, and because you can use Nix the language to describe build processes and dependency trees, that means that you can build real artifacts reproducibly in Nix, from simple packages all the way up to container images and even entire Linux systems in the case of Nix OS. And because Nix can put bytes on disk reproducibly, that means that it can provide declarative development environments where you can say, hey, I want these packages and environment variables available inside this specific project. And using that, you can elegantly sidestep Docker images and bash scripts and README instructions and make files and just jump straight into synchronizing project specific development environments across developer workstations and CI and production systems of all kinds. Finally, with runtime closures, when it comes time to actually deploy things, you can ensure that when you run a system in production, its entire dependency tree is available at runtime. So you don't end up relying on some dynamic library or shelling out to some CLI tool that simply isn't present. And closures aren't some special feature of Nix, they're just how Nix works, and they're just part of the Nix worldview. Second, Nix promises to unify all this stuff, your packages, your environments, your containers, your Linux systems, via the Nix language. And having an actual language is vital here because unlike Bash or Docker files or whatever, all of these constructs can mingle and interrelate in really fruitful ways. So you can declare a package here and throw it in a container and image there or a Nix OS system there, and it all just magically hangs together. But in its earlier days, Nix only sort of lived up to this promise, as it was largely built for and sustained by what I call a hobbyist mentality, and I think in some ways it still is. This has had a variety of consequences. First of all, installing Nix is always pretty tricky because it involves things like creating a bunch of system users, downloading and starting a daemon, and working with storage volumes. And yet, in the core Nix project, the official installer has always been a kind of good enough but pretty shaky bash script, although that is beginning to change with Determinate Systems' help. Another good enough aspect of early Nix is the widespread adoption of channels as the standard way to receive updates. So with channels, you basically subscribe to a branch of Nix packages or maybe some other package sets and build everything based on that. The problem is that inputs like Nix packages are massive, and if you're using those as your dependencies, then your updates can become rather chaotic as you grapple with breakages. So every 6 months, a new Nix package's release comes out, and you have to spend hours and hours fixing the multitude of problems that arise from this very ungranular update process. Another problem is that inside your Nix code, two machines evaluating the same expression can end up with different results. So you've probably seen these import Nix packages declarations. And when you see that, what you're seeing is impure evaluation, as two machines can very easily be quote unquote seeing two different commits to Nix packages. On the ergonomic side of things, the Nix community originally gravitated toward having a series of .nix files inside of projects that serve different functions. So you'd have shell.nix for dev environments, for example, release.nix for deployment stuff, but there wasn't really a fixed structure for outputs in Nix projects. And so to figure out how things work in a new project you'd like to rely on, you'd have to poke around or dig into source code. In the sphere of caching, which, as we know, is an essential construct in Nix, to the extent that, as I'm fond of saying, Nix without caching is basically a different and very flawed tool, the community has largely gravitated towards public caching models. The most widely used example is cache.nixos.org for Nix packages, which is pushed to by a CI system called Hydra. Now, cache.nixos.org has literally millions of packages in it, and everyone relies on it, and that's amazing, but it doesn't take much to imagine the problems with that from a security perspective. Additionally, public caches like this typically use a public-private key pair scheme for authentication, which, like any and all schemes involving static credentials, is not particularly flexible or robust. The end result of all this, well, I think one is indeterminacy, where all the way from installation to evaluation to using dependencies, you end up with what feel like small but substantial violations of the core Nix philosophy. Another result, as I've suggested, is that the security picture of pulling from monolithic public caches and using static credentials is not super compelling, especially in more security-minded organizations. With the advent of Flakes a few years ago, what we see is a decisive turn in the right direction. So instead of channels, Flakes introduced the flake.lock file, which pins all of your inputs or Nix dependencies to specific Git commits, which in turn paves the way to truly reproducible evaluation. So any two machines, so anytime two machines run Nix build or Nix develop or Nix run against the same Nix expression, they're going to evaluate to the same result. This doesn't eliminate every possible problem, but it does eliminate an entire category of indeterminacy. Prior to Flakes, people did find ways to pin things using tools like niv or npins or Nix's built-in fetch tarball function. But the difference is that with Flakes, you can't not pin things. And that means that your entire dependency tree in Nix has to abide by the same contract when you're using Flakes. Another breakthrough is that with Flakes, you no longer have various .nix files serving various functions. Instead, you have structured Nix outputs, where outputs can be packages or library functions or NixOS configurations or whatever. Flakes make Nix code much more discoverable and introspectable using commands like nixflake show or nixflake metadata. Flake schemas, which are a Nix feature that Determinate Systems is currently working on, these structured outputs become even more powerful because you can choose and design your own introspectable output structures. With that, it's just much easier and natural for Nix projects to rely on each other, which I suspect will eventually make the world of Nix code much more localized or decentralized. From my perspective, because Flakes have this built-in reproducibility and interoperability, they provide a much better building block for using Nix in larger organizations. But a building block is just that, a building block. There are things that Flakes by themselves don't provide and realistically shouldn't or couldn't provide. One of those things is access control. On its own, Nix kind of generally assumes that you're working with publicly available Nix code hosted on forges like GitHub and GitLab, and that is typically how people use it. You can use private Git repos as Flakes, but you need to make sure to properly configure SSH, which can be a hassle. And it also means that Git and SSH define your access control model, which doesn't always map well onto Nix, especially for use cases like deployment. Another thing that Flakes don't provide on their own is semantic versioning, or semver. So if you're used to language package managers that do provide version constraints and smooth upgrade paths, this might feel like a major lack in Flakes. The result of not having semver in Flakes is that updating them remains a bit like updating channels, kind of uncomfortably similar to channels, where you just kind of pull the most recent commit of a branch and hope for the best. So Flakes are a huge step forward, but when it comes to large organizations, they just aren't quite there on their own. But at Determinate Systems, we've been working hard on fixing that and fulfilling the promise of Nix in an end-to-end platform that we call Determinate. Now, Determinate has two core pillars, which Jeff briefly mentioned before. The first is Determinate Nix, which is our downstream distribution of Nix. Right now, Determinate Nix is basically fully synced with upstream, but it will soon offer features not yet available there, such as parallel evaluation. With Determinate Nix, we've made installation a first-class concern. So no more bash script that kind of works some of the time. Instead, we wrote an installer in Rust that supports many architectures and provides built-in support for uninstallation, which the official script does not provide. You can install Determinate Nix using curl. You can use our graphical installer from Mac OS, and we provide support for MDM platforms like Jamf. In larger organizations, getting Nix onto developer workstations and other machines is vital, and we've spent years tackling this specific problem. Determinate Nix is also hardwired to take advantage of Flake Hub. Now, Flake Hub is the platform that we have been building around Flakes for the last 2 years or so. It provides some of the crucial missing functionality in Flakes that I mentioned previously. So first, it provides semantic versioning, which pushes Flakes decisively beyond the channels model of just polling whatever's latest and towards a much more granular model. Flake Hub also goes beyond the current standard model of using source forges like GitHub and GitLab for serving Flakes. This model does work because those platforms do enable you to pull flakes as tarballs, but it's almost like they work by accident. They aren't purpose built to serve flakes. With Flake Hub, we store your flakes as tarballs in several S3 regions, and you basically pull them directly from there. And that means no arbitrary rate limits, and it also means not being subjected to the downtime that strikes source forges now and then. And I'm sure that you've all run into these rate limiting issues when using flakes, and I'm sure that you have woken up to lose half your workday to GitHub being down, and we're working on that problem directly. Another core component is Flake Hub Cache, a new binary caching concept for Nix. So unlike traditional Nix caches, Flake Hub Cache provides federated authentication for platforms like GitHub and AWS, so you don't have to mess with static key pairs anymore. And finally, provides private flakes using the same federated authentication model. And this enables you to keep Nix code private without resorting to clunky mechanisms like Git plus SSH. So in general, Flake Hub enables you to treat your Nix code much more like the secure infrastructure that it truly is than some of the older ways of doing things in Nix. So now that we've covered some of the capabilities that we've made available, we can outline some core best practices against that backdrop. I'll start with some best practices for flakes. So one best practice is to use semver when possible. So anytime you're packaging something that itself follows semver, make it follow semver in Nix as well. And if you're not using semver for that thing you're packaging, well, why not? Semver can apply not just to CLI tools and things like that, but also to things like running services. So why not have version 1.4.0 of your authentication service or 0.2.5 of your main web application? Why not opt to roll back to version 0.2.1 of that same web application, and then roll forward to version 0.2.4? Heck, maybe even use Nix adoption in your organization as an excuse to SEM verify your internal stack. The benefit of semver, of course, is that for anyone using that flake that's semantically versioned, updates become much more smooth and sane. Now, this is basically the antithesis of the old model of updating Nix packages once every 6 months and kind of saying a prayer. The benefits accrue more and more. The more, sorry, the the benefits accrue more and more the more you use Nix internally. I apologize for that clunky sentence. We have a handful of semver things that we package internally at Detsys, and it's really transformed all of our internal processes, and it's unlocked all kinds of deployment and organizational patterns that we couldn't imagine otherwise. Another best practice is to update your Nix inputs often. When you do this, you can resolve issues surrounding updating in a very piecemeal, gradual way over time, rather than dealing with periodic train wrecks. For Nix packages, we built a tool called Flake Checker that helps you keep Nix packages up to date and either warns you or fails your CI runs if your Nix packages inputs are more than n days old, where 30 days is the default, but you can be much more stringent than that if you wish. We've also built an action called Update Flake Lock that updates your Flake inputs on whatever cron schedule you choose. Some other best practices for flakes. So first, don't be bashful about splitting things up into separate flakes. In the Nix community, there's a sort of an allergy to this and an impulse to centralize, but we don't really understand why. Flakes are a great mechanism for dividing things up into smaller units, and we encourage you to really lean into that. Now, there are no hard and fast rules for how to divvy up Nix outputs across flakes, and there are many potential models. A good rule of thumb, though, and this could be controversial, but you should strive for one flake per versioned thing. So if you're packaging some version tool like a CLI tool or a service like a database, just create a separate flake for it. If you're packaging an internal service as a NixOS configuration, create a separate flake for it. Now, I know what you're thinking. Isn't this just a conspiracy by Big Flake to sell more Flake, where Determinate Systems is basically Big Flake? Well, no, we actually built Flake Hub specifically to make it possible to use as many flakes as you need. And I think this is true of a lot of things that we build, is we have a best practice in mind, and we seek to create the tooling around that. You can divide things when it comes to splitting things in flakes. You can divide things up by domain. So maybe you have one flake with all of your Nix OS configurations, and then one flake per team dev environment. You can split up flakes based on language. So you have a flake for all of your Rust utilities and packages, one for Python stuff, etc. You can split it up by team, where the DevOps team puts all their stuff in a single flake, while the developer productivity team has their own. Really, there's all kinds of models surrounding this. At Detsys, we created a GitHub action called Flake Hub Push that makes publishing flakes fairly trivial. So I say, when in doubt, just create a new flake. The option of consolidating flakes, if you decide you have too many, is always open to you down the road. And I think it's generally easier on you in the long term to just have lots of flakes and consolidate them when necessary than to have a few flakes and split them up. Another best practice, and this may also be controversial, is to forgo some widely used flake libraries like flake utils and flake parts when you're structuring your actual flake code. So there's nothing intrinsically wrong with these libraries. They work well. The people who make them are great. But from our perspective, you can get everything these libraries provide using either built-in Nix functions or helpers from Nix packages. When you add helper dependencies like this, everyone who uses your flake now has to import them, and that can have a cascading effect. So I frequently see flakes that are trying hard to be nice and lean, but they have a dependency on a flake that uses flake utils or flake parts, and their dependency tree ends up with all these extra nodes in it that, in my view, aren't necessary. And I think organizations can eliminate a lot of, I guess you could call it waste, by just keeping it really simple here. Another vital domain for large organizations is, of course, security. And Nix brings with it some special security considerations that don't necessarily apply to other languages. So first, it's extremely important to keep secrets out of the Nix store. Now, keep in mind that the Nix store isn't your typical file system where you just run ad hoc operations and read, write, copy, and delete stuff. Instead, the Nix store is basically an instrument that Nix uses to function properly. And so when you write something to the Nix store, it can be very non-trivial to get it out. Now, this is especially urgent when it comes to caches. So if you're using Flake Hub Cache, we don't yet have a way to scan for secrets or hashes or other sensitive information, but we're looking into it and hoping to provide something like that soon. Instead, you just need to remain vigilant and put and whatever security practices you have around not pushing secrets to caches, you need to push those as far left, so to speak, as you possibly can. Relatedly, people ask us occasionally if they should use tools like SOPS Nix or Age Nix for secrets management in Nix. Our perspective is that tools like that are usually fine for smaller orgs for deploying NixOS machines for personal use. But in larger organizations, we pretty much urge you to avoid static secrets entirely. Now, that might mean using Vault or some kind of cloud service, but this isn't an area where we recommend taking many chances. Another major pillar here is to follow what we call the principle of least access for Nix things. For flakes, that means making your flakes private unless you absolutely need to distribute something to the general Nix using public. And it also means providing access to those private flakes only to those who really need it. And the reason for this, why private flakes? Well, it's important to always bear in mind that when you have access to Nix expressions, you can actually build runnable stuff. And if you can build runnable stuff, you can find out all kinds of things about the inner workings of an organization. Now, this is kind of true of other languages, of course, but there is something fundamentally different about being able to build an entire Linux system with one command, versus being able to build like a Python tool with one command. And I think that makes restricted access to Nix code especially urgent. For caching, that essentially means eschewing public caches whenever possible and preferring trusted private caches. So public caches like cache.nixos.org have lots of good stuff in them, of course, but they're massive. And when you pull from them to build production systems, you're working with a pretty shaky trust model. We built Flake Hub Cache specifically as a private cache with no public access whatsoever to fill this gap in some traditional approaches to Nix caching. I also want to say a little bit about organizational adoption, because I think if you can't establish a reasonable adoption narrative, then it's hard to sell decision makers on Nix, especially risk-averse decision makers. And let's face it, in software, virtually all important makers are extremely risk averse because they have to be. One good way to further adoption is to spread knowledge. Now, despite the best efforts of many, Nix remains a tough pill to swallow in terms of building up an initial understanding. And because of that, education can be a really, really crucial vector to adoption. I'm, of course, very biased here, but our Zero to Nix guide is specifically designed as not just a Flake centric, but also as a hands on resource for people to learn Nix. So if you have folks in your org who are curious about Nix, but still not sure what the deal is or even why they should care, this might be a good thing to pass on to them. In addition to that, there are, of course, many good community resources like Nix.dev that are geared toward people who are just beginning to get a toehold in Nix. In addition to spreading knowledge, I also recommend taking a piecemeal approach to adoption. So bringing Nix into the mix can be a bit disruptive in some ways, but fortunately, because it does so many things, there are lots of ways to expand usage slowly over time. For example, you can show measurable gains to using Nix for development environments on a single team, and then you can start using Nix to package deployable services on that team, and then you can bring in another team to use it for their dev environments, and so on. You could also, for example, use it only for some of your less critical services, and only when it's demonstrated value, slowly migrate it into some more critical domains. Or you can choose a more ad hoc approach, like using it for your Python projects and then expand it out to your Rust projects and then onto your PHP projects and so on. Ideally, of course, at some point, you would be able to unite everything under the Nix umbrella and live happily ever after. But we know that that's not how how large organizations work. And fortunately, Nix is really quite good at filling in these smaller gaps and expanding over time. And that's it for now. Thank you again so much for stopping in, everybody. Like Jeff said, this is our first webinar, and I think it went pretty well. But it's still a bit fresh for us, and we look forward to improving over time. If there are any topics you'd like to see us cover, please let us know in the Q&A, and we'll be sure to make note. To learn more about our work, check out our blog, check out Zero to Nix, and check out our official documentation. And always, feel free to reach out to us either on Discourse or via email at hello@determinate.systems.
Awesome. Thank you so much, Luke. That was really good, and I agree. I think it was great for our first webinar. So we have some questions coming in, and I'm going to try to get to as many of them as we can. There's a couple that are a little bit longer, so if I don't read your question here, we will follow up with you if you don't mind us doing so. I want to respect your privacy, obviously, but we can follow up with some others. So a couple quick ones here. First one. Skipping Flake utils means that you have to implement the features they provide yourself. Does that not make things more brittle?
Uh, I don't think it makes things more brittle because so in all of our flakes at Determinate Systems, we basically have about 3 lines of Nix that we copy into each of our flakes, and that gets us. So I think the major reason that people use Flake utils is because providing the per system outputs. So you want to provide a package output, packages.art64darwin.default that building that attribute set on a per system basis isn't really hardwired into Nix. I'd be happy to share our little snippet that we use. It's just like 2 or 3 lines, and you can kind of adapt it to your purposes. And those functions are really quite simple. So I don't think that it necessarily makes things more brittle, and it does mean that if you remove one Flake utils dependency from a dependency tree, then let's say if you have a flake that's relied upon, by A, B, C, D, E, F, G, the benefit of not having that Flake utils dependency there, it's one fewer network hop in each, and so on and so forth. I think the benefits are pretty immense when you think about flakes as this kind of accumulative thing.
Right on. Here's another one for you. What's wrong with Git plus SSH? Why do you think it's clumsy, Luke?
Well, I guess it's clumsy because So Nix is this special tool that enables you to do lots of fun stuff. And Git plus SSH is fine for a limited set of use cases. But I don't want it's like I don't want Nix to be subservient to somebody else's to some other tool's access control model. Like I want Nix to have its own native access control model or an access control model that's provided by a platform, which is what we do with Flake Hub. So let's say, for example, on my developer machine, okay, so I set up my SSH credentials to use GitHub and everything works. I have access to my org's private repos, like that's fine and great, pretty okay model. But then all of a sudden, I'm running a system in production, and like let's say a NixOS system, and I want to pull in the new closure for that specific system. So like I write some Nix code, push a new Nix configuration that gets built, and then I want to pull that directly onto that machine. Well, do I want to use Git plus SSH to provide access control now? Do I want to configure this? Do I want to have to configure this production system the way that I configure my own developer workstation? I mean, maybe like that kind of works, but I'd really prefer not to. I would really prefer to just use the authentication strong constructs that are native to whatever platform I'm running on, whether that's AWS or whether I'm, building something in GitHub or whatever. And so I think it's an okay model and it works for a lot of people and thousands of people use it, but we just wanted something qualitatively better.
Great. Um, the another one is this is a suggestion, and that is that Determinate could provide templates to avoid things like the flake utils. And I agree. I think Determinate should provide templates for making it easy to follow best practices. Would you agree, Luke?
Yeah, I do agree. So we have a tool called FH, which is the CLI for Flake Hub. And FH has this command called FH init, and what FH init does is it basically looks at your repo and it asks you some questions. It says like, oh, I notice you have a cargo.toml here. Is this a Rust project? Oh, I notice you have a requirements.txt. Is this a Python project? Do you have a package.json? Is this a JavaScript project? And what it does is that it automatically generates flake.nix for you, which I think is kind of handy in some cases, especially when, for me, like writing a flake.nix is second nature, but it took me years for that to become second nature. So we provided that specific tool for that use case. So you just don't have to think about it. But I would say, in addition to having this FH init thing, the problem is that you need to install this whole other tool, and maybe you don't want to use the Flake Hub CLI, maybe you don't need it. So having something like ready-made templates, I think that's a great idea. I do have I'm gonna put a I do have this thing that I built personally. I don't mean to push one of my own projects, but I have this dev templates project which you might want to take a look at. So this is where I provided development environment templates for lots and lots and lots of different languages, and they do so in accordance with what I personally see are best practices for Flakes. But having something in determinate systems, having some encoded best practices in public repos, or maybe even some Flake templates would be quite nice.
Yeah.
Yeah. So
Another
Fern,
one.
I just sorry, Fern, I did provide okay. Thanks a lot for providing that, Max.
Cool. Here's a related question on something a little bit different. You mentioned earlier the flake checker. Where can people find that?
The Flake checker is at so I'm gonna do another. That's it on GitHub at Determinate Systems /Flake checker. And there's also it should be noted there if you add dash action, there's a Flake checker action repo as well. And you can use just a couple lines of YAML, and you can throw that into pretty much any project using Nix pretty trivially.
Maybe we'll do one or two more and then try to end soon. So another question is, um, do I have to use flakes if I choose to use determinate?
Um, no, at the moment, no, because you may be aware of the nix dash star command. So nix dash build, nix dash env, and a few others, which are sort of like nix dash build, especially is kind of built around an assumption of channels. Nix dash build is sort of blind to flakes, and that does so. The old CLI commands do come bundled with determinate nix, and probably will for the foreseeable future until the unified CLI is ready to go. Yeah, you certainly can. There's nothing preventing you at the moment, but we just think that flakes are such a qualitatively better experience of using Nix, due, like I said, due to the introspection, like the built-in inputs. That yeah, I guess I wouldn't recommend it. and and of course, Flake Hub, unsurprisingly, if you want access to private flakes, if you want access to Flake Hub cache and things like that, those are built around flakes as a kind of central construct or primitive. So no, I would say go nuts. Like if you want to use channels with determinate Nix, you're more than welcome to. But there may come a day when we don't support the older CLI commands anymore. But we would certainly give a lot of advance notice for that.
Got it. That's great. Yeah, I think, obviously Determinate is bullish on flakes. And it's definitely something that we believe in, but you don't have to. So let's see here. Last one, I can take this answer. And it is, what does it mean for a feature to be available in determinate NICs, but not available upstream? I think, this is referencing determinate NICs 3.0 and our plans there. The features we ship in Determinate Next are all submitted as pull requests upstream. That is our commitment. That is our goal. And we're committed to having those PRs merged into Nix upstream when the team wants them. But in the meantime, we also want our Determinate Next users to have access to those things, and we'll do the work necessary to remain compatible while delivering, the experience that we know that Nix at Work users have. So that's it. I could actually address one more question, only because I think it is something that folks bring up. Actually, you know what? We don't have time, so I'm gonna get going. I'm gonna leave you hanging on that one. Maybe we'll just talk about that thing in our next webinar. But thank you all for attending. We've enjoyed it. I think it went pretty well. We're excited to do more of these. In closing, the session was recorded, so I can send that out. So be on the lookout for more from us. We can also send out some links and ask you for your feedback through the tool we use for the registration page. If you're interested in learning more about Determinate's products for Nix at Work, check out determinate.systems. And remember, we exist to make Nix simple, secure, and confident in the enterprise. That is our purpose. That is why we are here. And if you'd like help crafting a Nix implementation strategy for your team or your organization, we'd love to offer some, free personalized guidance. So shoot us an email to hello@determinate.systems, and we can get something set up and give you some advice. Obviously, we'd love for you to use our products, but we will do it in an unbiased way to help you be successful with Nix, because that's something that matters to us. So that's it for today. Thank you so much for joining, and we will look forward to the next one. Have a great Thursday.